All right, today we're going to do geometric sequences. Sounds exciting, I know. It's the only other sequence we're going to study because it's not arithmetic, it's geometric. We use geometric growth in calculus when we're solving um, some exponential problems and things like that. So, geometric sequences. First of all, just a bit of review. An arithmetic sequence has a common difference, um, and that is by adding and subtracting. So the common difference is you add or you subtract the same thing each time. All right? To each term. The equation for that was a sub 1 plus d times n minus 1. And then for a series, you had a partial sum, n over 2 times the first plus the last. And then obviously you can substitute this equation in for a sub n, you get your three equations. So you're going to come up with things like that for these geometric sequences. This is arithmetic, next is geometric, try not to get them confused. I'm sure you'll be fine. Okay? So let's get started. Everybody pay attention, get out their stuff, and here we go. So the geometric sequence is if you multiply by something to get the next term. So you have to multiply by r to get the next term. And so that's the biggest difference right there between arithmetic. Arithmetic, you add or you subtract. With r, you either multiply or you divide. Remember, this is the next term, and this is your current term. Okay? So to find it, it's easy enough. You just divide the next term by the current term, and you're on your way. R is known as the common ratio. All right? Also, you have to put in positive integers for n, and you can figure it out that way. For instance, here's a common geometric sequence. Let's go with 3, 6, 12, 24, 48. You can see that the common ratio is going to be 2. Okay? So, and that's by multiplying. One of the more difficult ones we'll get to is when you have something like -2, 4, -8, and then you have 16, and r is -2. R can be a positive number, R can be a negative number, it can be a fraction, but you see the alternating negative. You never saw that with the arithmetics. So that's kind of different. Moving on. Show that the given sequence is, I don't know what this means. So that the given sequence is geometric. And find the common ratio. Okay. 1, 3/7, 9/7, 1/7. What are you multiplying each one by? Well, obviously you're multiplying by 3. If you take 3/7 divide by 1/7, you can sledge out the 7s, and you end up with 3. Okay? So that's why 3 is the common ratio. Here's a little equation. Coincidentally enough, this is the nth minus term. This is a sub n. It equals the first term times r to the n minus 1. That's your nth term. So when you see these in the problems, they're getting used to seeing that notation, and they're letting you know ahead of time what your equation is going to be. When you put this in the calculator under sequence, you remember the whole sequence thing we had? You can go to sequence, and you can type in parentheses 1/7, and then 3. And remember, you don't need a parentheses around the 3. And remember, when you do this, 1/7 times 3 caret to the x minus 1. You need parentheses around both the x and the 1. So there's a comma x and a comma. In this case, it'd be just 1 to 3. You would never see this term. That just generates it, but you can see these. Then you can go to frac it, and you would see the 1/7, 3/7, and 9/7, okay? Now, this dot, dot, dot means you're stopping at the nth term. This is the nth term of that sequence, okay? All right, sounds good. We're moving on. The sequence a sub n is geometric if the formula a sub n equals, well, I just told you what it was, a sub 1 times r to the n minus 1, okay? A sub 1 times r to the n minus 1. That's for geometric. This is for arithmetic. Why am I bringing them up so much? I've seen hundreds of people get these mixed up on a test, and they get a poor score. All right, here we go. Find the nth term, fifth term, and eighth term of the geometric sequence. Well, you can tell that you're dividing by -3. Remember, that's the same thing as multiplying by -1/3, okay? Dividing by -3 is the same thing as multiplying by -1/3. So, with that said, it's pretty easy that the first term is 162. Then you have the -1/3 to the n minus 1. That equals your nth term. I don't know, can't get much easier than that. So, oops, sorry, these aren't filled in. Interesting. So, the fifth term, take a sub n equals 162 times -1/3 to the 5 minus 1. A sub n equals 162, and then you have -1/3 to the 4th. Punch that out. I'm sorry. That's a sub 5. Oop, need this. There we go. A sub 5. So you take your calculator, take 162 times -1/3 to the 4th, and you end up with 2. So the fifth term is going to be 2. The eighth term, a sub 8, well, you put 8 in there, you get 162, -1/3, 8 minus 1. You can punch that out. All you got to do is change the 4 to a 7, and you end up with -2 27ths. So the eighth term is -2 27ths. All right? There are all three answers. Nicely done. Okay. Moving on. Find all possible values for r for the given geometric sequence with two given terms. A sub 3 is 4, and a sub 7 is 1/4. So, this is kind of cool, this type of math. I'm going to use this equation, a sub n equals a sub 1 times r to the n minus 1. I'm going to set up two equations. I usually do this equation first because it has a higher number. So I'll take 1/4 equals a sub 1 times r to the 6th power, because you have 7 minus 1. And then I'll set this equation up. I'll have 4 equals a sub 1 times r to the 2nd power. Now you can't add these because you're multiplying, so you're going to have to just divide these terms, and then that'll give you your answer. You divide each one. What is 1/4 divided by 4? That's easy. I don't care if you do it on a calculator or not. It's 1/16. A1 divided by A1 is just 1. That's the whole reason you do this. This is the elimination method for multiplying and dividing coefficients. We did the elimination method earlier for linear equations. This is the one for geometric terms and sequences. So a sub 1 divided by a sub 1 is just 1. You don't even have to write it down. And r to the 6th divided by r squared is r to the 4th. If you take the fourth root of 16, of 1/16, you should get, I believe, 2. 1 divided by 16, the fourth root of it, and yeah, you get 1/2. So r is equal to 1/2, and that actually could be, no, it has to be all positive. I guess it could be negative. I guess it could be plus or minus. Because the first term would have to be, you can either have an 8 or negative 8. You could have plus or minus 8 multiplied by 1/2, and you get, already it has to be negative or positive. So yeah, I'd probably just go with the positive. I'd go with positive or negative. You can make it both work. Anyway, you could have a 16, an 8, a 4. That's where a sub 3 comes in. Then you can have a 2, a 1, 1/2, and a 1/4. This is where the a sub 7 comes in. 1, 2, 3, 4, 5, 6, 7. Now I'm saying these terms could all be positive or negative in this one, I'm guessing. All right? A negative times a negative is a positive, and a positive times a positive is a positive. So yeah, it could be either way. All right, good. Well, let's try another one. Given geometric sequence, find a sub 2 equals 3 and a sub 5 equals a1, find r. This is more of the same we just had, where we have to divide the two equations after we set them up. Excuse me. So you have a sub n equals a sub 1 times r to the n minus 1. Again, I like that one first because of the exponent. Negative 81 equals a sub 1 times r to the 4th, and 3 equals a sub 1 times r to the 1st. Divide the two equations, you get negative 27 equals r cubed. Again, a sub 1 divided by a sub 1 is 1. You subtract exponents when you divide those, and you get negative 27. So r equals negative 3. Okay? That's the cube root of negative 27. You have it in your calculator, you have a cube root button. It's under math, which is right below alpha, and it's option number 4 on my calculator. You can type it in, and you end up with negative 3. Okay? Excellent. Moving on. Here are some partial sums equations for a geometric sequence. A sub 1 times 1 minus r to the n, all divided by 1 minus r. There's another one you could do with this if you wanted to. That could be a sub 1. How would that work? Don't worry about it. Well, if we need it, we'll come up with it later. I'm not there right now, so I better not do stuff like that. And this is kind of cool. If this is an infinite geometric series, if the absolute value of the common ratio is less than 1, in other words, if it's a fraction less than 1, the sequence will converge. We talked about that. You can actually add up an infinite list of numbers to get a sum. That's pretty cool. So, those are your two equations. Jot them down. And we'll use them as we move on. Okay? Everybody have them? Right, you should have them. If not, well, then you weren't paying attention. All right, there we go. Oh, evaluate the following sums. I don't even need that for this. I can put it in the calculator. Like we talked about earlier, you can do sum sequence of the negative square root of 5. You're going to parentheses right there on your calculator. Raised to the x, comma, x, comma, 1, comma, 9. Okay? And you should be able to type that out. Y equals, let's see. I'm going to type it out with you since I don't have these already done. Math, list, sum, and list, sequence, then your equation, then your variable. Your lower bound is 1, your upper bound is 9, and you come up with, well, I came up with negative 966.36909. Something like that for an answer. I don't know. That's what I came up with. So I just put in some sequence of all that, typed it out, and got that answer. Okay? Any questions on that? Just kidding. All right, we're moving on. Try this one. This one's got K's and J's in it. This is interesting. I wonder what the J's are supposed to do. I don't know. I'm just going to list it out. It's not that many terms. So 3 to the first plus 2j squared plus 3 squared plus 2j squared. I'm just putting 8, then 9, then 10, then 11, then 12, then 13, then 14. So it doesn't take that long. Plus 3, turns out it's going to be cubed when I put in 10, plus 2j squared. And then you get 3 to the fourth plus 2j squared. That's what happens when you put in 11, plus 3 to the fifth plus 2j squared. That's how you do 12, plus 3 to the sixth plus 2j squared. That's how you put in 13, plus 3 to the seventh plus 2j squared. So all these 2j squareds are going to add up. 2, 4, 6, 8, 10, 12, 14. That's what I got. If I'm off, let me know. I'll fix it. And then as far as the numbers go, it's 3 plus 9 is 12, plus 27 is 39. So this first part is 39, plus, heck with it. I'm just going to use my calculator. Sum sequence, 3 to the x, 1 to 7. There you go. How's that? Some sequence. I already got it up here on the calculator, so it's not that big a deal. 3 caret x, comma, 1, 2, 7. 3279 plus 14j squared. Okay? Sounds good to me. There should have been 7 terms because 8 from 14 is a distance of 6. You count the end, you get 7. All right. Questions on that one? Good. All right, we're moving on. Express in summation notation. Remember, this could be over a 1. So, looks to me like there are 1, 2, 3, 4, 5 terms. I always like to start mine with 1, sometimes 0. Looks like the top number doesn't change. Looks like the bottom one does. This is like to the first power. This is like 5 squared, 5 cubed, 5 to the fourth. This one, I guess, could be 5 squared, or 5 to the 0. So, we can do 5 to the n minus 1, and we just figure it out like that. Looks pretty easy to me, doesn't it? Put in 1, you get 0. 2, you get 5. Excuse me. Sounds good. So that's what's known as summation notation. Now, if you want to get really picky, you can find the nth general term, which would be 3 times, the common ratio is 1/5, and you can put to the n minus 1 power, which is the same thing I have. There's lots of ways of writing it. That's another way you can write it. Sometimes I just think about it right like that. So, moving on. Only 5 slides left. Try this one on your own. Come up with a summation for the infinite, and I'll put an infinite right there. Oh, it says find the sum. Nice. Well, I'll put infinity right there. And I'll put down n equals 1. And the equation is 2 times 1/3 to the n minus 1. Well, I can tell that because the r is 1/3. Now, if you put this in your calculator, you're going to put in a big number for the upper bound. If you're not going to put it in your calculator, remember we said if r is less than 1, the summation for the infinite geometric series is the first term divided by 1 minus r. We've already established that r is a third. So, simple arithmetic tells you it's 2 divided by 2/3. So that would be 2 times 3/2, which would be 3. Does that seem right? I don't know. You put your calculator in some sequence, and you put in 2 times 1/3 to the parentheses x minus 1, comma x, comma 1. I don't know, maybe 99. See how that works? It might take a while, but at least you know it's working for you. And you end up with 3. Yeah, so I went up to 99 just to check it out, see if it would work. And it does. So that's pretty good. All right, next. Find the sum of the infinite geometric series. All right. Well, you just had to know r. What is r in this case? Well, if you take if you take 9/4 divided by 3/2, you can take 9/4 times 2/3. And you end up with r equals 3/2. Well, so we're in good shape because r is equal to 3/2, which means this is actually bigger than 1. So the sum would be infinity because it's known as divergent. It diverges. It doesn't settle off to one specific number. It bounces around and it finally takes off and goes up, and it doesn't come back down. You can tell that if you put it in your calculator, you'd probably get an overflow error if you did a really high enough number. So in that case, r is equal to 3/2, so the sum would be infinity. The only other answer you could have for that would be negative infinity, if they were all negative numbers. So, but you don't, so you can't, so we're moving on. Okay, slide 13, there we go, 14. Find the rational number represented by the repeating decimal. 10.5 repeating. You can put this in your calculator with enough 5s, you can frac it. The reason it's in this section is because you can take 10 and add, how's that work? Add 5/9. Maybe 10 and 5/9 is your first one. I don't know. I just put it in the calculator and frac it. Actually, I don't even do that. I just know that if it's repeating, if it has 1 bar over it, that number gets put over 9, 10 and 5/9. If you have a number, say this one, 10 and 23, with 2 lines over it, that means it gets a 99 over it, 23, 99. That's how I do it. I don't use the geometric series or sequence to come up with it. It's got to have something to do with 10 10.5, I don't know. I don't even want to look it up. I'm too tired. Been a long day. So, but that's how I do it. You can use frac on the calculator, or you can just know it. Probably better if you just know it. You can frac it on the calculator. You have to get enough decimals. You have to get at least your first line filled up, I would think. All right, find the geometric mean between 20 and 25. This is old school. The geometric mean comes from a right triangle that has the altitude drawn from the right angle to the hypotenuse. Okay? The geometric mean is this number x. This is a 20, that's a 25 in this problem. It said that if you take x times x, that equals 20 times 25. Well, the short of it is x is equal to the square root of the two outside numbers. Mean means middle. Geometry means it comes from a right triangle. So you got the square root of, 500, is that right? 25 times 20, 500. Then if you want, you can rationalize that. So it's going to be 10 square roots of 5. Okay? 100 times 5, so it's square root of 100. Excellent. All right. The yearly depreciation of a certain machinery is 25% of its value at the beginning of the year. The yearly depreciation of a certain machine is 25% of its value at the beginning of the year. If the original cost of the machine is $20,000, what is its value? That means what's it worth. If it depreciates 25% a year, that means it holds on to the value of 75%. So you're looking for the nth term value after 6 years. So there's always a debate. Does the 6 involve the first year? Does it not? Blah, blah, blah. Oh, no, this makes it pretty clear. This was the beginning of the year. So that means it lost 25% in one calendar year. So that means you're looking for the 6th year. Some people think it'll be in the 7th, but that's when you're done with it, I think. Anyway, but the key is that 75% of the value is the same as 25% depreciation. So you just take the 20,000, multiply it by 0.75 for the percent, raise that one to the 6th. You should come out with $3,559.57. Okay? Excellent. So, with all that said and done, I believe it's homework time. And in this section is 9.3. The assignment is going to be page 721, I believe. And you're going to do numbers 1 through 53 odd. When you're done with this, there's going to be, go ahead and get out a piece of paper, and you have a small homework check. That homework check is going to be out of section 9.1. And out of 9.1, I want you to do the following problems. And this one, I'm turning my book now. That's an infinite sequence and series summation notation. So, homework check, or a 5 for 10 on, let me get my pen up here. 5 for 10 on page 705. Numbers, nice, 11 through 55 multiples of 11. Okay? 11 through 55. Oh, wait a minute. Check that. I don't want to do that. There's a problem on there I just saw. Strike that. So the 5 for 10 will be on page 705. And I think we'll do multiples of 9. 9, 18, so far so good. 27, 36, and 45. Okay? So put your name on those, turn them in, and who's over my place will take those. And then once you know that, go ahead and get started on your homework. Great. Thank you very much, and have a great day.